here we have an elevator car that has a mass of 1,000 kilogram. It's carrying passengers having a combined mass of 600 kilograms. It says there is a constant frictional force of 4,000 newtons retards its motion upward. And it wants us to find what must the minimum power delivered by the motor to lift the elevator up at a constant speed of 3 meters per second. So before we do anything, I'd like to point out wording here. It says find the minimum power delivered by the motor. So I'm going to focus my attention on the motor itself. So to find the minimum power by the motor, so I'm just going to P for power. Here's the subscript motor. I need the work done by the motor over a certain amount of time. So if it's power done by the motor, you need the work done by the motor divided by time. Well, I don't know what the work of the motor is because it's not given to me, but what I can do though is I can break up work is equal to force times displacement. Well, what force? If it's work done by the motor, it would have to be the force of the motor times the displacement and over T. Okay. So here in the free body diagram, I'm just going to go ahead and draw it out here. The arrow pointing upward, that is your F by the motor because the motor is going to start winding and that's going to pull on the cable and the cable is going to pull the elevator up. So here I'm just going to call this is the F by the motor, and acting against it is the weight of the system, and F of G here, it includes the mass of the elevator car and the mass of the folks riding the elevator, which is 600 kilograms. And then in addition to the weight though, pointing down, you have a frictional force that's acting against the upward motion. So in this case, friction is going to point downward because the elevator is moving upward. And I'm just going to call that F of K. You can call it F of friction if you want. All right. So what's important here is this particular wording phrase, constant speed. Constant speed implies that it's just cruising. And if something is just cruising upward, it is not accelerating. So here in the diagram, I made a note, A is equal to 0. Constant speed implied that it's not accelerating. So therefore, the statement is true. So in order to find F motor, though, I need to set up Newton's second law. I have F of the motor pulling the system upward. Acting against the F of motor pointing upward are these two vectors pointing downward, which is Fg and Fk. So I'll go ahead and subtract it. So F motor minus F of K, because it's acting against it, minus F of G and minus F of K because both these are acting against it. And that equals to MAY. Well, I know what AY is because it's saying constant speed of 3 meters per second. So AY is equal to 0. M times 0 is just 0. So in order to find F motor, I need to get rid of negative F of G and negative F of K. So I'm just going to go ahead and add both those terms to the right, doing the opposite operation. So instead of subtracting, I'm just going to add it to both sides. Okay. So I can say F motor is equal to the magnitude of F of G plus F of K, which makes sense. In the diagram here, there's only one force pulling the system upward, but there are two forces acting against it. So the force upward must equal to the two forces downward added together because acceleration is equal to 0. All right, here I know F of G can be broken down to mg, but you got to be super careful here. You're given the mass of the car by itself and then the mass of the passengers combined. So here, even though F of G can be broken down to mg, make sure you plug in the right mass. Here I'm going to plug in the total mass because the cable or the motor is doing work on both the cart itself and the people riding in the elevator. So it'd be 1,000 kilogram plus the additional 600 kilograms for the people. Okay, times 9.8. Once again, this is positive 9.8 because the negative signs are being accounted for. And then plus 4,000 newtons. So if you add this all up on your calculator, you should get a value of 19,680 newtons. So this is how much force that the motor is outputting. Okay. All right. Other than that, now that we know F motor, the only thing that's holding us back really is delta Y and T. Well, I don't know what delta Y is because the problem never specified anything. I don't know how much time because once again, the problem didn't mention anything about time. But what I can do though is recognize that delta Y over T is just my average velocity because by definition, displacement over time is your average velocity. Well, what's your average velocity then, right? We just found F motor, so the only thing holding us back now is our average velocity. Well, when A is constant, average velocity can be calculated using VF plus VI divided by 2. Okay, this particular step is a little redundant if your kinematics is really, really strong. If not, you should definitely listen to it closely. Hopefully after this, you can stop thinking about this kind of stuff because it's always true. All right, so average velocity is equal to VF plus VI divided by 2 under the condition that A is a constant, which it is in this case. All right, VF, well, what's VF? Well, it says that it's moving at a constant rate of 3 meters per second. So at any point in time for this particular problem, VF is going to be 3. Well, what's VI? Well, VI is also 3 because it's moving at a constant rate. Well, 3 plus 3 is 6. And then 6 divided by 2 will give you a value of 3 meters per second. So this is important. I like to point out here that we just did all this to find that the average velocity is 3 meters per second. However, when a is equal to 0, your average velocity is also your instantaneous velocity. Why? Because you're moving at a constant rate. So at any point in time, which is your v of t, that value stays the same. So when value stays the same, when you add the two values together and divide by 2, you get the same answer. Okay, so anytime after today, or after this video hopefully, when you see constant speed of anything, the average velocity will always equal to the instantaneous velocity. Alright, so now that I know v average is 3 meters per second, I can just use that here. Alright, so the average power exerted by the motor or delivered by the motor is simply going to be the F of the motor, which is 19,680 newtons, times the average velocity. And the average velocity in this case is the same as the instantaneous velocity, which is given as 3 meters per second. So if you simplify that on your calculator, you should get an answer of 59,040 watts, and that is our answer. Okay. What I'm about to point out is what some folks likes to and be tempted to do. You might be tempted to say power is net work over time, and if you do that, you might break up net work into net force times delta y here, or just y here. However, if you do this, I like to point out that net force in this particular problem is 0, because the system is moving at a constant rate, which means acceleration is 0. If acceleration is 0, F has to equal to 0, or the net force has to equal to 0. Well, if net force is equal to 0, which I did over here, 0 times any displacement is just 0 divided by anything is just 0. So you end up getting a power of 0 watts, which makes no sense, okay? So it's important that as you practice, you understand what is being asked of you. So for this problem, it wants the power delivered by the motor. So you have to focus your attention on the work of the motor and the force of the motor, not net work, okay? Net work is different than work of just the motor. All right, so this is a big no-no. That's a big misconception. So as you practice, as you get answers, make sure it makes sense. All right, stay nerdy, don't be whack.